So today we're going to start a brand new chapter. This is chapter 8. Talks more about geometry. We get into shapes and area and things like that. So I want to split today's lesson into 2 days. Today is just going to be about ideas and vocabulary, and then tomorrow we'll talk more about calculations. So we start this chapter off with circles. It is one of my favorite sections of the year because circles are so unique and have things that are just for them. We get to study those. It's pretty cool. So let's talk about what a circle is. Yes, it's a round thing, but the mathematical definition is a set of points equidistant or equal distance from a center point. So here is a perfectly drawn circle. I used a tool called a compass, and I'll show you how to do that in just a second. So I made a dot, and this line you think of as a line. It's not. It's a bunch of dots, a bunch of points so close together that it looks like it's one continuous piece. And because that one continuous piece is curved, we call it a circle. If I was to pick a point anywhere on this outside line, maybe here, or here, or here, those points are all the same distance from this center point we called A. Now, circles even get their own symbol. It's a little circle with a dot in the middle, so it doesn't look like an O, and then whatever the letter is for the center point. So this would be called circle A. Okay, now let's talk about how we do this. If a circle is a bunch of points the same distance from a given point, we got to have a tool that keeps it the same distance. So you might have seen, and I'm going to kind of make this kind of crude, you might have seen something that looks like this. It's like two, almost like a V, and they're attached at the top. And one side is a point, and one side is like a pencil. We used to use them in class, and then I wised up because I don't like giving middle schoolers things with really sharp metal points. But instead, we have something like this, okay? And I'm going to show you how this works. This is called a safety compass because it does the same thing. It just doesn't have those sharp metal points. So I'm going to make a point, and then I'm going to hold this here. I'm going to put my pen in one of these dots, and you can change how far away. That's going to change the size of your circle, okay? And then it just swings around. And by holding my finger in the same spot, and by keeping the pencil the same distance, it makes a perfect circle all the way around. I used to do an activity in the spring outside with sidewalk chalk. So the sidewalk chalk was the pencil, and then we would just hold a string, wrap a string around it, and hold that at one point, and we could make perfect circles on the ground. All right, so let me show you how you're going to do this. So here's my dot. I'm going to call this my center point, right? You can see, I hope you can see, there's kind of like a little mark on the inside so that you can see exactly where to put it, right? Like that. Now I'm going to make this be small. So I'm going to move this in very close. Okay, I'm going to hold this there, and I put the pencil in, and then I just drag it around. Now there comes a point where my fingers get in the way, so I cheat and I move the paper. But this pencil was the same distance from my other finger the entire time. It didn't move, well, until I got to here and didn't do it so well, right? It was the same distance here and here and here, all the way around. That pencil was the same distance away. Now, if I wanted a bigger circle, I would just move the pencil further away. This is not going to fit. I can tell you right now, it's going to go off of the card because, see, I'm keeping it the same distance the entire way, and it makes the circle. That's really what a circle is. You've kept the same distance the entire time. Keep that in mind as we start to talk about calculating things for circles, okay? All right, let's talk about a radius. Now, a radius is a line, technically a line segment, that goes from the center anywhere on the outside. It's kind of like half, so it could go here, it could go here, anywhere along. One is radius, more than one is radii, singular versus plural. Then we've got diameter, and that goes from side to side, but it must go through the center. There is something else that goes from side to side that doesn't go through the center. We don't talk about them in 7th grade. Okay? Now, if you are good with your prefixes, dia can mean across. You might even think of di meaning 2. If I take 2 radii, right, and put them together, I get a diameter. So radius is 1, Diameter is 2 of them. It's twice as long. All right, let's talk about this idea of pi. Pi, not P-I-E. Pi is a number. It happens so frequently with circles that we give it its own symbol. It's the Greek letter for pi, or for P. This is the Greek letter P. Pi is a non-repeating decimal. It is a non-terminating decimal, which means it's going to go on forever. And it is also an irrational number. And you know the ir means not, and rational can be written like a ratio. So this number cannot be written like a fraction. We found one that's pretty close, and I'll talk about that in a minute, but it cannot be written as a fraction. It's not like it's 0.2, where I just say, oh, that's 2/10. Okay, so pi does go on forever and ever. They found something like 1 million digits because our supercomputers just keep going. We usually only use the first 3.14. That is perfectly accurate for the calculations that you and I will be doing. Perhaps if you were sending someone to like Mars, you might want to be a little bit more accurate and you would use a few more digits. But for us, 3.14 is perfect. If you remember back in March, we celebrated Pi Day on March 14th. That's why. Now, if you have fractions, 22/7 is the closest fraction we can find. The beginning part is the 3.1415, I think, and then it changes a little bit down here. We don't need to be that specific. Okay, so either 3.14 or 22/7. Pi does not change. Okay, pi will always be pi. Now, there are 3 formulas I'm going to give you. First of all, let's talk about circumference. If you know the word circumnavigate from social studies, like when the explorers would circumnavigate the globe, that means that they go around. Well, circumference goes around the outside of the circle. It's like the perimeter. Why circles needed their own special name for it, why we couldn't just call it the perimeter of a circle, I have no idea. But circles think they're special, so they get their own name. Whatever. Okay, so there's 2 formulas. Which one you use depends on the information you're given. And when we start calculating tomorrow, this will make more sense. One option, if you're given the diameter, right? If you know the number that goes across, just multiply that by 3.14. But if you're not given that number, if you're given the radius instead, you're going to do 2 times pi times the radius. These 2 together, the 2r, is the same as the d. It's really the same formula. We'll talk more about that tomorrow. The other formula that you need to be familiar with is for area. Now, I know you've talked about area for other shapes, and it's how much it takes to cover it, right? And we measure it with squares. So my floor might take, 900 square feet of tile to cover. It's a very similar thing. We're going to cover a circle with squares. All right, parts of squares because it's a circle, but we're still measuring it with square inches, square feet, square yards, whatever. The formula for that is pi r squared. And this always helped me remember the units, right? So this is really 3.14 times radius times radius. What happens if you only have the diameter, right? What happens if this is the information you're given and you need to find the area? Well, you're going to have to cut this number in half. And we'll talk more about that tomorrow. But what I really want you to set your brain around is the idea that circle is a bunch of points, same distance from a center point. You can measure from the center out or straight across. And there are 3 formulas that you're going to have to be familiar with. You don't have to memorize them, but you have to be very comfortable with using them. Okay? And we will talk about those specifically and how to calculate tomorrow.